Most of your mathematical lives, you've been studying real numbers. Real numbers include things like 0 and 1 and 0.3 repeating and pi and e, and I could keep listing real numbers. These are the numbers that you're kind of familiar with. And then we explored something interesting. We explored the notion of, well, what if there was a number that if I squared it, I would get to negative 1? And we defined that thing, that if we squared it, we got negative 1. We defined that thing as I. And so we defined a whole new class of numbers, which you could really view as multiples of the imaginary unit. So imaginary numbers would be I and negative I and pi times I and e times I. So this might raise another interesting question. What if I combined imaginary and real numbers? What if I had numbers that were essentially sums or differences of real and imaginary numbers? For example, let's say that I had the number, let's say I call it z, and z tends to be the most used variable when we're talking about what I'm about to talk about, complex numbers. Let's say that z is equal to the real number 5 plus the imaginary number 3 times I. So this thing right over here, where you have a real number plus an imaginary number, and you might be tempted to add these two things, but you can't. It won't make any sense. These are kind of going in different, well, we'll think about it visually in a second, but you can't simplify this anymore. You can't add this real number to this imaginary number. A number like this, and let me make it clear, that's real, and this is imaginary. A number like this we call a complex number. A complex number. It has a real part and an imaginary part. And sometimes you'll see notation like this, where someone will say, well, what's the real part? What's the real part of our complex number z? Well, that would be the 5 right over there. And then they might say, well, what's the imaginary part? What's the imaginary part of our complex number z? And then typically the way that this function is defined, they really want to know, well, what multiple of I is this imaginary part right over here? And in this case, it is going to be 3. And we can visualize this. We can visualize this in 2 dimensions. Instead of having the traditional 2-dimensional Cartesian plane with real numbers on the horizontal and the vertical axis, what we do to plot complex numbers is on the vertical axis, we plot the imaginary part. So that's the imaginary part. And then on the horizontal axis, we plot the real part. We plot the real part, just like that. We plot the real part. So for example, z right over here, which is 5 plus 3i, the real part is 5. So we would go 1, 2, 3, 4, 5. That's 5 right over there. The imaginary part is 3. 1, 2, 3. And so on the complex plane, we would visualize that number right over here. This right over here is how we would visualize z on the complex plane. It's 5, positive 5 in the real direction, positive 3 in the imaginary direction. We could plot other complex numbers. Let's say we had the complex number a, which is equal to, let's say it's negative 2 plus I. Where would I plot that? Well, the real part is negative 2, and the imaginary part is going to be, you can imagine this is plus 1i, so we go 1 up, it's going to be right over there. So that right over there is our complex number. Our complex number a would be at that point of the complex, let me write that point of the complex plane. And let me just do one more. Let's say you had the complex number b, which is going to be, let's say it's 4 minus 3i. Where would we plot that? Well, 1, 2, 3, 4, and then, let's see, minus 1, 2, 3, or negative 3 gets us right over there. So that right over there would be the complex number b.